Alright guys, let's look at lesson 3, which is half reactions. Half reactions. They show either the oxidation or reduction portion of a redox reaction. That includes the gaining and losing of electrons. Alright, every redox reaction consists of two main components, an oxidation half reaction and a reduction half reaction. So let's look at an example. 2 Mg plus O2 gives us 2 MgO. So we would have to assign oxidation numbers first. Both Mg and O2 are elements, so they're both 0. Then when we look at the formula MgO, we have a +2 for Mg and a -2 for O. So now we have to identify what's being oxidized and what's being reduced. So the first thing is we have to remember Leo says GR. So when we gain charge, when we go from 0 to a +2 charge, remember that's oxidizing. Oxidation gains charge. When reduction, you lose your charge. So we go from 0 to -2. Then what you would do is you'd write out those two reactions. Okay, so MgO with a 0 oxidation state breaks into or is turned into Mg plus 2, and then to balance it, it would be +2 electrons. O2 plus 2 electrons will give you O minus 2. So then that's the oxidation part because it lost electrons. That's the reduction part because it gained those electrons. And we have a loss of electrons here, and so the oxidation number increases, and we have a gaining of electrons here, so the oxidation number goes down. So there are some rules for setting up half reactions. So rule number 1, you're going to assign oxidation numbers to all the elements in the reaction and determine if it's a redox reaction. So that's what you're going to do, is you're going to have to first determine if it's redox. And the easiest way to do that is to see if there's a change in the oxidation numbers of two of the elements in the compounds. So here are all of our oxidation numbers. So is an oxidation or a reduction happening? Yes. If you look, copper here and copper here have different charges. Silver here and silver here have different charges. So this is an oxidation reduction reaction. The next step you want to do is determine which species is being oxidized or losing electrons, and then which species is being reduced, which one's gaining the electrons. So let's look at that. So our copper is being oxidized because it lost 2 electrons, and the silver is being reduced because it gained an electron. So then what we're going to do is we're going to break up the overall half reactions into the oxidation and reduction part. So oxidation is copper 0 going to copper plus 2. The reduction part is silver plus 1 going to silver 0. So then the next step, we have to fill in electrons for each half reaction. If it's being oxidized, then if it's being oxidized, then the electrons are going to be lost, so that means that electrons go on the right-hand side. If it's being reduced, then electrons are gained, so the electrons have to go on the left-hand side. So in this first oxidation of Cu with 0 oxidation state to Cu plus 2, we have to add 2 electrons on the right. And then on the left, for the reduction half of it, we have to add 1 electron on the left, so that makes that charge balance. Now we have to check to see if the charges are equal on both sides of the half reaction. So our charges are equal, everything adds up, and we're neutral. So this is a practice problem. We're going to do this in class because it will be a little bit easier, but let's walk through it just in case. So say you have this calcium equation plus copper plus 2 gives calcium plus 2 and copper solid. So assign all your oxidation numbers. Figure out what's being oxidized and reduced. So calcium is going from 0 to plus 2, so it's losing electrons. And copper is going from plus 2 to 0, so it's gaining electrons. So then we split up into our two half reactions. What's being oxidized, so that's our Leo part. And what's being reduced, that's our GR part. Remember, if it's oxidation, you have to put the electrons on the right-hand side. If it's being reduced, the electrons go on the left-hand side of your equation. Change and make sure that your oxidation number is increasing when you have an oxidation reaction happening, and that when it is being reduced, that your oxidation number is decreasing. So when we balance redox reactions in all of them, there's a conservation of charge and mass. Okay, so what if we wanted to balance a redox reaction? So let's look at this original equation that we looked at a couple slides ago. So write out the two half reactions, make sure to include where the electrons go, then multiply the half reactions by the number of electrons in the other half reaction. So, and then multiply through and put the resulting coefficients into the original equation. So let's look. So here are two equations. We have to multiply the top one by 1 because that's the amount of electrons that the redox had, and we have to multiply the bottom by 2 because we want our charges to be equal. Remember, now mass and charge are conserved. So let's look at for when we balance this redox reaction. Okay, so we're going to do an example, but this one we're going to do in class. So we're going to do this one in class tomorrow. But I want you to try that one, your practice, and check your understanding. All right, so let's look if these reactions are going to happen spontaneously. So if they're spontaneous, then they're going to occur without adding energy to the system. And how do we know if they occur spontaneously? We use table J in your reference packet. So remember, if the single element is more active than the combined element, then the reaction will be spontaneous. So in this case, zinc is more reactive than lead, so that reaction will take place. If it's non-spontaneous, then the reaction will not occur unless you add energy to the system. So when we compare zinc to aluminum, that reaction, it will not happen. So remember, on your activity series on table J, they're listed from more reactive metals on the top to least active metals on the bottom. So the ones that are at the top are most easily oxidized, and then that goes down. So that means that they're the easiest ones to lose electrons. If they're at the bottom, that means they're not easily oxidized, so that it's hard for them to lose electrons. So same thing with your nonmetals. More active nonmetals to least active nonmetals. The nonmetals are going to be the ones that are going to be most easily reduced at the top. And that means it's easy for them to gain electrons because remember, nonmetals like to gain electrons. And then the ones at the bottom are not easily reduced because it's very hard to take for them to gain electrons. So let's look at a practice. Comparing nickel to aluminum, which would be oxidized and which would be reduced. So the first thing you would want to look at is where they are. So oxidized would be aluminum because it's higher up on the chart. And then nickel would be the one that's more reduced because it's lower on the chart. So tomorrow we're going to go over that example, practice, and check your understanding, and we'll see you then.